Hello students, welcome to the class. My name is Ravi Thakur and today we are going to study how to integrate trigonometric twins. What are trigonometric twins? Student, these functions which are shown on your screen, which is root tan x, root cot x, dx over sine to the power 4x and cos to the power 4x, dx over sine to the power 6x and cos to the power 6x, a plus minus b cos x and a plus b sine x into cos x. These functions are few of the examples of trigonometric twins. Why they are known as trigonometric twins? Because since they contain trigonometric functions, and also when you will integrate these functions, you will find that after few steps of integration, they are going to become same. They are going to be solved using same method, same procedure, and they will involve same functions to be integrated. Okay, so that's why these are known as trigonometric twins. Okay, so let's get started and see how we can integrate these functions one by one. Okay. So let's take first function for example, which is root tan x. So suppose we have a function to integrate, which is root over tan x dx. So we are going to use substitution method to integrate it. Okay. So let's see the steps. So first of all, we will let tan x is equals to t square. Okay. So to convert it into the function of t, the whole integration into the variable of t, we are going to differentiate it. So differentiating both side tan x, derivative of tan x will become secant square x into dx, and derivative of t square with respect to t will become 2t into dt. Okay. So in this case, we can find the value of dx as 2t dt over secant square x. Okay. Now, since we know that, a student, that secant square x is nothing but 1 plus tan square x. It is trigonometric identity. Yeah. So we can also write it again as like this, 2t dt over 1 plus t to the power 4, since tan x was equal to t square. Okay. So by substituting this value in place of dx and in place of tan x t square, our integration will now become under root t square into 2t dt over 1 plus t to the power 4. Okay, so further we can write it as 2t square dt over 1 plus t to the power 4. Okay, now we have to integrate this function. Okay, so now what we are going to do, students, is that we are going to separate this 2t square as t square plus t square. Okay, divided by 1 plus t to the power 4. Now I'm going to add plus 1 in the first t square and subtract minus 1 from the second t square. Okay. So after all, after adding them, 1 and minus 1 will get cancelled out and we will left with the same value 2t square. Okay. So it is nothing but just a manipulation, algebraic manipulation here. Okay. So now I'm going to divide both the fractions t square plus 1 by 1 plus t to the power 4. Again, t square minus 1 by 1 plus t to the power 4. Okay. And taking integration on both of them separately, because we know that on plus sign we can take the integration separately. Okay. So now it has become two different integration. Let's say it is I1 and it is I2. Okay. So now we are going to solve both the I1 and I2 separately, and their sum of addition will give the integration of our value of our integration, required integration, which is root tan x. Okay. So now let's integrate I1. So I1 is nothing but t square plus 1 over t to the power 4 plus 1 into dt. Okay. So what I am going to do is that we are going to take t square common from numerator and denominator both. Okay. So it will become t square 1 plus 1 by t square over t square into t square plus 1 by t square into dt. Okay. Now here you can see that, a student, t square and this t square will get easily cancelled out. So our integration will become something like this, 1 over 1 plus t square over t square plus 1 by t square into dt. Now, what I'm going to do, student, is that look at the sign present in the numerator. What is the sign in the numerator? It is 1 plus. There is a plus sign in the numerator. Okay. So what I'm going to do is convert the numerator into a minus b whole square form. Okay. So if the plus sign is present in the numerator, convert it into the a minus b whole square sign. If the minus sign is present in the numerator, convert it into a plus b whole square. Okay. So this whole integration will become something like this, 1 plus 1 by t square. So I can write it like this, t whole square plus 1 by t whole square minus 2 times t into 1 by t and plus t. Okay. So 2 times t into 1 by t will become t and t get cancelled out. It will become minus 2. So I have added plus 2 also to make it equal. Okay. So that the value of the numerator do not get changed. Okay. So by this, we can easily see that the whole integration has become something like this, t minus 1 by t whole square plus 2. Okay. dt. So I can write this integration as 1 plus 1 by t square, okay, t minus 1 by t whole square plus root 2 whole square, okay, into dt. Now this questions can be converted into particular function, integration of particular function, okay. So what we are going to do, we are going to again substitute substitute t minus 1 by t is equals to suppose z, okay. So on differentiating both sides with respect to x, differentiating both side with respect to x, with differentiating both sides, it will become like 1 minus 1 by t square plus 1 by t square, since the derivative of 1 by t is minus 1 over t square into dt is equals to dz. Okay. So in place of 1 plus 1 by t square into dt, you can write dz. So your integration will become now dz, I1 will become dz over z whole square plus root 2 whole square. Okay. Now, by the integration of particular function, we know that the integration of this function will be 1 by a, which is 1 by root 2, tan inverse z by x by a. So in place of x, we have z upon root 2. Okay. Plus c1. So this will become something like this, 1 by root 2 tan inverse 1 plus, sorry, 1 minus 1 by t over root 2 plus c1. Further, we can say that this will become tan inverse, on taking LCM, it will become t minus 1 by root 2t plus c1. Okay. Now, what was t? T was equal to, look at here, we have substituted earlier, tan x is equals to t square. So from here, you can see that t will be nothing but under root tan x. Okay. So in place of t in the I1 integration, we can substitute root tan x. So whole integration of I1 will become under root 2, 1 by under root 2 tan inverse root tan x minus 1 over root 2 root tan x plus c1. Okay. Now let's say it is equation number 2, because we have to substitute this I1 value into the equation number 1 to get the whole solution. Now let's integrate I2. So what was I2? Let's go over there. So I2 was this function, which was t square minus 1 dt into 1 plus over 1 plus t to the power 4. So this was the I2. Okay. Now we have to integrate this function. So what I'm going to do, again, I'm going to take common t square from the numerator and t square from the denominator. Okay. So this will become something like this, 1 minus 1 by t square over, if I take t square common from denominator, it will become 1 over t square plus t square. Okay. Into dt. Now t square and t square will get cancelled out. So the whole integration will become something like this, 1 over 1 minus t square over 1 t square plus 1 by t square, and write it like this. Okay. Now, what is the sign in the numerator? Sign in the numerator, students, it is 1 minus 1 by t square. So you are going to convert the numerator into a plus b whole square form. Okay. So I'm going to write it something like this, t square plus 1 by t square, let me write it again, okay, plus 2 times t into 1 by t, okay, and minus 2, okay, into dt. So the whole integration will become something like this, t plus 1 by t whole square minus 2 into dt. Okay. So this integration will become nothing but 1 minus 1 by t square, t plus 1 by t whole square minus root 2 whole square into dt. Okay. Now again we are going to repeat the same process which we have done in the I1 integration, that we are going to substitute put or substitute t plus 1 by t is equals to, like, suppose u. I'm going to let it u because earlier we have let it z. Okay. Again, on differentiating with respect to uh, t, yeah, differentiating with, so again differentiating both side, differentiating both side. Okay, this will become something like this: 1 minus 1 by t square into dt is equals to du. Okay, because integration of t with respect to t will be 1, and integration of 1 by t with respect to t is minus 1 by t square. Okay, so in place of minus 1 minus 1 by t square into dt, you are going to write du, and in place of t plus 1 by t in the question, we are going to write it u. Okay, so this whole integration will become something like this. So I2 is equals to du over u square minus root 2 u square. Okay, so integration of this function will be 1 by 2a. So in place of a, we will write root 2 log mod u minus root 2 divided by u plus root 2 plus c2. Okay, so this integration will become 1 by 2 root 2 log, in place of u we are going to write t plus 1 by t plus 1 by t minus root 2 divided by t plus 1 by t plus root 2 plus c2. Okay, and what was the value of t? Let me take LCM first. So I can write it like this: t square plus 1 minus root 2t divided by t square plus 1 plus root 2t divided by t. Okay, so t and t will get cancelled out. So this whole integration will become something like this: 1 upon 2 root 2 log mod t square plus 1 minus 2 root t divided by t square plus 1 minus plus root, sorry, root 2t plus c2. Okay, now in place of t we are going to write root tan x. Okay, so the whole integration will become something like this: log t square, in place of t square we are going to write tan x plus 1 minus root 2 tan x divided by tan x plus 1 plus root 2 tan x plus c2. Okay, so these are going, this is going, we are going to call it equation number 3 because this is the value of the uh, I2. Okay, so from equation 1, 2 and 3, what our integration was nothing but I1 plus I2, and the value of I1 we got is something like this: 1 by root 2 tan inverse root 2 tan inverse plus C1. So in place of I1, I'm going to write it, and in place of I2, we are going to write this integration value, which is 1 by root 2 tan 2 root 2 tan x log this. Okay, so I'm going to just copy and paste here. So this is our final solution. Just one thing more, that you can write it like this: tan inverse root 2 tan x minus 1 over root 2 tan x plus 1 by 2 root 2 log mod tan x plus 1 minus root 2 tan x divided by tan x plus, sorry, tan x plus 1 plus root 2 tan x mod plus c, capital C. Okay, because since C1 also belongs to real number, C2 also belongs to real number. Okay, so the summation of C1 plus C2 will be also a real number. Let's say that is C. Okay, so in place of C1, C2, in on adding both of them, you can write it as C. Okay, so this was the integration of our uh, trigonometric twins, which was root tan x. Okay, root which was root tan x. Okay, so this is how we integrate the trigonometric twins. Okay, I hope you understand the concept. you are able to comprehend it. Okay, we are going to see other trigonometric twins, how to integrate them in next lecture. Okay, till then, take care.